Hello everyone. Let's discuss about what is Cartesian product of two sets. First we'll discuss about two sets, then there can be three or more than three sets for which we can find the Cartesian product. The Cartesian product is also called as cross product. Now it's a product of two sets. Suppose A is first set and B is the second set. Now A cross B, that is the cross product or Cartesian product of set A with set B, is defined as ordered pair. Now you see, ordered pair means you plotted the points in Cartesian system, right? X-axis and Y-axis. So there the ordered pair, say 2, 3 was different than 3, 2, right? The order is important, the sequence is important, that is why it is called as ordered pair. So AB such that A is in A, first element is in first set and second element is in second set. That's the Cartesian product. Like, suppose I have set A as AB, okay, or 1, 2. We take it as 1, 2 because we have already used capital AB. Let's not take again the same to get confused. And suppose set B is X, Y, Z, right? Now I want to find A cross B. I said A cross B is ordered pair AB. So first element has to be from A because I am finding A cross B. Second element has to be from B. So 1x, 1y, 1z, 2x, 2y, 2z. Right? That is the Cartesian product of A and B. 1x, 1y, 1z, 1x. If I have to draw the diagram, and these diagrams are called as arrow diagrams. If I have to draw this arrow diagram for the Cartesian product, A has 1 and 2, B has x, y and z. So 1x, 1y, 1z. 2x, 2y, 2z. That's the Cartesian product of A and B, the Cartesian product or cross product of two sets. Now, when we said ordered pair AB, it means first element is in first set, second element is in second set. That gives us a simple and very obvious conclusion that if I have A cross B, then it is not going to be same as B cross A. Because B cross A would be defined as BA such that B will belong to B and A will belong to A. Right? That means the definition itself tells you that A cross B is not same as B cross A. That is, the cross product of two sets is not commutative. Now, the next thing about this cross product is, if I continue with this example, the elements in A are 2, number of elements in A is 2 and number of elements in B is 3, right? Whereas if you see the number of elements in A cross B, 1, 2, 3, 4, 5, 6, there are 6 elements. Understand, this is a single element. Ordered pair is one element here. So if I have number of elements in A, it's say M, and number of elements in B, it's say N, then number of elements in A cross B, that is the cross product, will be M into N. That many elements. This cross product, if I have the product of two sets is given to be, say, I am given now A cross B as say 3, 7, 1, 5, 1, 1, right? Then say 5, 9. Clear? Now, from the product I want to find the sets. So, A would contain, the first element is from A. So, A would contain 3, 1. We won't write 1 again, we write only once, one element once and then 5. Right? A has 3 elements and B will have 7, 5, 1 and 9. Now tell me how many further elements will come in A cross B. This has 3 elements, this has 4 elements. So 3 into 4, 12 elements. I have listed only some elements of the cross product. Yes, and then from that I ask you to find the sets and complete the cross product. So you can complete now. 3, 7 I have already listed. So 3, 5. Right? Then 3, 1. I have not listed that. Whatever is missing I should complete that. Then 3, 9. Then 1, 7. 1, 5 is already there. 1, 1 is already there. 1, 9. Right? 5, 7 is not listed still. 5, 7. 5, 5 not yet listed. 5, 1. 5, 9 listed. And you see the cross product will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements. Whereas A has 3 elements and B has 4 elements. And also observe one thing. 1, 5 is different than 5, 1. It's called as ordered pair. Sequence of terms would be important. Therefore, if you are given some elements of the Cartesian product and told to find the elements of the set, you can do that also. If in the ordered pair, the next thing which I am discussing is, suppose you are given x plus 1 and 5 is equal to 3 and 2y plus 8, right? If the ordered pairs are equal, that will mean the corresponding elements are equal. So this will mean x plus 1 is 3 and 5 is equal to 2y plus 8. That is, if the ordered pairs are equal, then the corresponding elements are equal. In the beginning I said we can find the cross product of 2 sets or 3 or more sets. Now how do we find that? So we have discussed about the Cartesian product of 2 sets. If I have to find the product, triple product I can say, suppose I have A as PQ, right? Now I can find A, cross product with itself. I can find A cross A also. I am showing how. So A cross A is cross product of PQ with itself. Yes, so we have the elements as P comma P, P comma Q, Q comma P and Q comma Q, that is 4 elements. Right? Now A cross A triple product will have 3 terms. So you see, you have A cross A here as PQ as one term, then P comma P as another term, QP as another term and QQ as another term, and then A is PQ, right? So it will have 8 elements now, and it would be PQ P, PQ Q. So how we write that? PQP, right? Then PQQ, go systematically, go in order. First element, then these two. Second element, then these two. So then I have P comma P comma P. then P, comma, Q, right? Then Q, comma, P. This is the way to write. Then Q, P, Q. And then the last element Q, Q, P and Q, Q, Q. That is, you will see that the triple product will have 8 elements because A has 2 elements. Like this we can multiply as many sets as we want. Understand, this is an important concept because relation is a subset of Cartesian product and a function is a subset of relation, which will continue in the next video. Thank you.